In our first video, we have learned different things related to environmental science, and since we are done with it, let us now proceed to our next discussion, which will talk about energy, matter, and cycles. But first, what really is a matter? Matter is anything that occupies space and has a mass in it. For example, a car which is very heavy and occupies space in the parking lot. Another example is a tiny atom, or even us, the humans. Papers, water, trees, and everything visible or invisible to human eye that occupies space and has a mass. Matter can change in two different ways. It could either be a physical change or a chemical change. A physical change refers to a change or distortion of something. Say for example, a clay. We can change the physical form of a clay by crafting it into something beautiful, or an artwork like a flower, animals, or even our idols in different movies and animes. The clay would still remain a clay since its chemical composition wasn't altered. Only its physical state had changed from a round clay to something wonderful. A chemical change refers to a change of an atom's chemical structure resulting to a new product. Say for example, the rusting of an iron due to oxidation, which slowly destroys not just the physical structure of the metal but also the chemical composition. Burning of paper and woods, digestion of foods, and spoilage of milks are also. The three states of matter are the solid, liquid, and gas. Let us take a look at solids. An example of a solid is our computer. The properties of solid depends on how the particles are being packed together. In solid, particles are closely packed in a fixed position and they cannot move anywhere. So therefore, solids are rigid and cannot be squashed, have fixed shape and fixed volume. They cannot flow. And now let us take a look at liquids. An example of a liquid is water. Same with solids, its properties depends on how its particles are being packed together. In a liquid, particles are closely packed together but not as close as the particles of solid. So this means that particles of liquid can move around each other. Therefore, liquids are not rigid like solids, but because their particles are closely packed together, they cannot also be squashed. They don't have fixed shape and they have a fixed volume so they can flow. Finally, the gases. Say for example, a helium. This is a gas commonly used in party balloons because it is less dense than air and unreactive. Again, same with solids and liquids, the gas properties depends on how the particles are close together. Unlike solid and liquid, the gas particles are not closer or packed to each other. This means that gases are not rigid. They can be squashed and compressed. They do not have fixed shape or even fixed volume, and its particles fill the whole space around them. And that's all for the three states of matter. And now let us proceed to the term energy. What is energy? Energy is the capacity of doing work. An object which can do more work is said to have more energy, and vice versa. For example, a motorcycle has more energy than a bicycle. Since energy is the capacity of doing work, therefore, the SI unit of energy is same as of work. 1 joule of energy is required to do 1 joule of work. Thus, the SI unit of energy is joule and is denoted with a symbol J. Larger unit of energy is kilojoule and is denoted with a symbol kJ. 1 kilojoule is equal to 1000 joule. The energy used to displace a body or to change the position of the body or to deform the body is known as mechanical energy. And this is one of the different forms of energy. Mechanical energy comes from two types: the potential energy and the kinetic energy. The energy possessed by a body by virtue of its position or due to state of strain is called the potential energy. If a body is in a position such that if it were released it would begin to move, it has potential energy. There are two common forms of potential energy. One is gravitational and the other one is elastic. Example: the work done to lift a body above the ground level gives the potential energy of the body, and this is a weight lifting. An example which shows potential energy. Gravitational potential energy. It is when an object is allowed to fall from one level to a lower level. It gains speed or kinetic energy due to gravitational pull. So therefore, in possessing height, a body has the ability to convert its height into kinetic energy out of from the potential energy. If a mass m is at height h above a lower level, the potential energy possessed by the mass is mass times gravity times height. Elastic potential energy. Same work has to be done to change the shape of a body. This work gets stored in the deformed body in the form of elastic potential energy. Elastic potential energy is never negative, whether due to extension or due to compression. Kinetic energy. Kinetic energy of an object increases with its speed. Kinetic energy of an object moving with a velocity is equal to the work done on it to make it acquire that velocity. Kinetic energy is always positive and is a scalar quantity. The fact that moving bodies carry energy with them is proved by some of the several happenings in our day-to-day life. Example: the kinetic energy of a hammer is used to drive the nail into the wall, and a bullet fired from a gun can penetrate into a target due to its kinetic energy. Actually, there are different types of energy that exist in the universe. But for this video, I will only include energies that drives up the ecosystem. The first law of thermodynamics states that energy can neither be created nor destroyed. It can only be converted from one form into another. Important energy conversions meet the energy needs of all organisms in the ecosystems. There are four important forms of energy to understand when thinking about ecological systems. These mainly are the solar energy, chemical energy, ATP energy, and thermal energy. Solar energy is the radiant energy from the sun. Sometimes we call this type of energy as light energy. Solar energy is used by plants and other autotrophs in the process of photosynthesis. Chemical energy refers to the energy that is stored in the chemical bonds of molecules. Organic molecules like glucose, proteins, and fats are rich in chemical energy. Living organisms obtain chemical energy from their food sources. ATP energy refers to the specific energy molecule that is directly used by the cell to power all cell activities. All organisms use the chemical energy available in food to produce energy, rich ATP, molecules. Thermal energy is the heat energy. When ATP energy is spent, the energy is not destroyed, rather, it is converted to heat and is released by the organism. This is why our body temperature increases when we are doing activities that spend a lot of energy. ATP energy is being used and converted into thermal energy. The sun is the original source of energy that powers the entire ecosystem. Autotrophs convert light energy from the sun into chemical energy in the form of glucose. This process is called photosynthesis. Glucose is rich in chemical energy. It is the original source of food that supports the entire food chain. A food chain shows the transfer of chemical energy. While producers can make chemical energy, consumers must eat to obtain the chemical energy. Chemical energy is transferred from producers to herbivores to carnivores. Why do organisms need a source of chemical energy? Organisms must obtain chemical energy so that they can produce ATP energy. Chemical energy is used by the cell to make ATP energy during the process called cellular respiration. ATP is used to power all cell activities, both in human and plants. When ATP is used by organisms, it is converted into heat energy and is released by the organism. To meet the energy needs of their cell, organisms must continually obtain chemical energy from their environment. Organisms are constantly obtaining, generating, spending, and releasing the energy. The energy needs the entire ecosystem rely on the sun, showing the interdependence of biotic and abiotic factors in an ecosystem. The nitrogen cycle. Nitrogen is another element in nature and it makes up about 70% of the air that we breathe. It is important for plant growth and all life in ecosystem. The basic process is the same as the carbon cycle. Nitrogen is cycled through the environment with the help of plants and animals, who will help keep the nitrogen in balance. And now let us review. Energy is cycled in our ecosystems from suns, producers, consumers, and thermal heat or the sun. Matter is also recycled. Some common cycles of matter are the water cycle, carbon cycle, and nitrogen cycle. Recycling matter is important because there is a limited amount of matter available on Earth. If nature did not recycle, we would run out of important materials necessary to sustain life. And that's all for this video. I am Julius Ilamazon, your discussant.